Hi, I'm Madison Sofield. I am our AI marketing strategist at Tomorrow.io, and we are here for our fourth episode of the Expert Forecast with Randy Chase, our atmospheric data scientist at Tomorrow.io. Welcome, Randy.
Hi, how's it
All
going?
right, we're super excited to have you, and we have some really cool questions to go over with you. So I'll just get us, just rolling. How would you explain your job to someone with no background in weather or science?
So I like to explain my job, especially to like my parents and grandparents who are not familiar with the scientific world that I work in. And it's kind of I'm a computer programmer at its most basic essence, but I tend to use my computer programming skills and artificial intelligence in the realm of weather. So I've been using weather data, whether it comes from satellites in space that are taking pictures of the Earth every so often, or if it's from your weather station in your backyard. I use those different weather data sources and combine them with AI and machine learning to give catered forecasts for different needs. So examples are like if you have a plane to fly, you want to know if you can see when you take off, or if rain is important for your event. I help cater some of those forecasts to those different needs and solutions.
Cool. It's awesome. It's like, when you're on the tarmac and the pilot goes, where we're landing is
Yeah, they
XYZ
give
weather.
the weather report, right? Yeah.
Yes, you help with that, which is awesome. I love it. Okay. What problem are you ultimately trying to solve, and why does it matter to someone watching the evening weather report?
So we've entered kind of a new age of weather forecasting. We've had a long history, and I say we, the community has a long history of using computers to forecast the weather. It started way back in the 1950s with some of the first computers ever used, and we started weather forecasting with them. And the way we've done it historically, I'd say in the past, say maybe 10 or 15 years ago to 1950, was we had these physics equations that would solve how the weather moves. And you would take your current best guess of the atmosphere right now, like the weather over Salt Lake City right now is 87 degrees. And then we would take these physics equations and move how the weather would be in the future based on our knowledge of physics. But what's happened recently in the past 5 to 10 years is that AI and machine learning has opened up a new paradigm of weather forecasting. So we gave these AI and these AI machine learning models, it gave them the task of just watching weather. We have this long database of weather reality that, or a simulated past of all of weather that's ever occurred in a really long record called the ERA5 record. And so we told AI and machine learning to say, hey, watch a lot of these forecasts of the past and just learn how the weather moves. And what that really unlocked is now we don't have to use a giant supercomputer to run these weather forecasts. What's been happening recently by Google, NVIDIA, and much smaller companies out there is that they can run these AI weather forecasts in a matter of minutes on a modest laptop or a GPU, if people are familiar. So part of that new revolution of weather forecasting is something that I've been trying to bring to Tomorrow is how can we leverage these new AI forecasting techniques within Tomorrow, and how can we best leverage these fast, computationally efficient weather forecasts for our customers. And specifically trying to ingest something novel that Tomorrow's doing is we have our own data set that we've been collecting on orbit for about a year now. So how do we ingest those satellite data directly into the forecast in a fast time so that people can actually make actionable changes to those forecast decisions?
Yeah, it's so cool working at Tomorrow because it's we're doing two really interesting things. One, we have our own satellite constellation, right? So we're getting our own data. But speaking with other, in our science team and understanding how like data assimilation works now, which I
Mm-hmm.
feel like I'm also learning so much through the series. Um, we are also right how we're doing it, how we're assimilating the data, how we're creating models, how we're using AI is also different. So really, we're offering something that no one else has, which is not just because of our models, it's not just because of how we do data assimilation. It's also because of like the data we're feeding it,
Mm-hmm.
which is like super exciting. In the past year that we have this new access to our own data. Um, Let me go to the next question. Let's
Sure.
see. Yeah. Okay. So this is a little bit more of a branch off before I think I want us to come back to AI, because I think talking about kind of how we're using AI models is really interesting, and really interesting to hear it from you, especially as you're working, on it yourself.
Hmm.
But I wanted to ask, like, how does knowing a satellite impact before it launches help communities become more resilient? So, we now have our own constellation up, right, of our own. How do we know it's going to be impactful to what you're talking about, like having our own access to data, and how does it impact communities with everything that we're talking about?
Yeah, it's still quite an open question, especially on the AI forecasting space. But the premise is that more data will create more accurate forecasts, and I think most people agree with that sentiment. But understanding how and what data we collect on orbit can then optimize how good the forecasts get. So you can imagine maybe if you take, is it important to take images from space at a regular interval, such as daily, or is it better to take them at 6 hourly intervals or maybe hourly intervals? So it all depends on the weather phenomena that you're kind of trying to forecast for. So these big synoptic cyclones that give us everything from thunderstorms in the south and snow up to the Great Plains in the northeast in the winter, those systems move at a much slower cadence, like on the order of days. So maybe you don't need a rapidly updating picture of those things. But if you're trying to forecast those individual thunderstorm cells that are propagating within this larger cyclone, you do need a faster cadence update. So I think the way we're kind of evaluating this, and it's one of the questions I'm looking at regularly, is what is the actual impact of our new TMS fleet on these forecasts of, if we only have one sensor, how does that impact the forecast versus if we had our whole constellation that we're trying to put up there? Yeah.
But actually, I thought that was a cool learning segment, because I didn't know that, like, some certain types of storms, you
Yeah,
don't
it's
actually see it
all
pass.
it's all based on scale. Like if
Yeah.
you're just trying to predict planetary scale waves, is what we call, and like these long, thousands of kilometers size systems, you don't need as frequent updates. I guess maybe the analogy is like, if you look at my shirt here, it's black, but if you zoom in closely, you can see all the individual threads that make it look like one coherent color.
Yeah.
So if you're zoomed away from far from Earth, you can see one coherent weather system. But within that weather system, there's little pockets of thunderstorms. There's a front pushing through that might have some snow along it. Those types of things that you're. It's all the scale of what you're trying to predict and how that eventually impacts the end. People
Yeah.
on the ground. If you're concerned about hail is a very localized event, and certain thunderstorms make hail. Not all of them make hail that hit the ground. So
Mhm.
having a much more frequent update and microwave update of those storms could definitely help on picking out which ones are starting to produce hail and where they might go.
Yeah. And I would say too, like, tying it back to like resilience, and we always talk about, like, it's a bit of our buzzword at tomorrow, at tomorrow, but it's because this is super helpful again for me. So I hope whoever's watching this finds this helpful. Right. It's some things don't need the fast tracking, but when you're dealing with things that do get impacted by weather, that can't get wet, that can't
Hmm.
experience hail, that does impact a business and the livelihood of a business, or you just think of like a day-to-day person, it does matter about that localization. So I think that does make you, like, more resilient, right? So if we think
Yeah.
about a shipping company and broader scale, they're like, oh, there's a storm coming in this week, but okay. But if they have, oh, well, we're going from, I don't know, Arkansas to Austin. These are horrible examples, but and within that route or at our facilities, we know that there's going to be a hailstorm, a lightning storm that would put our drivers at risk. That means that we probably shouldn't have that shipment go on the road, and we should wait XYZ hours or days to do that. That's a big deal. It makes a huge difference.
Yeah,
And I
that's
think it's
something
really
we've
cool that you
been
distinguish it.
we've been building on the AI front. I don't know if people are familiar with the focus model that we've announced a few times online. Is That's exactly what we're aiming to do. Is we take real-time observations at a cadence that, say, every 15 minutes, and we can update our weather forecast to give us 3 kilometer, which is the distance between you and a grocery store probably.
Wow.
So like a 3 kilometer box update every 15 minutes that we can run so that we can get that hyper local uh, concerning information. So if you could decide if you wanted to wait an hour until that storm passes over the highway and then can avoid the hail, that's kind of the information content we're trying to strive for.
I need the just, well, I guess they do have it, but maybe I should just check the Tomorrow IO platform more regularly living in San Francisco.
Mm-hmm.
I think
Yeah,
you
San
might, you're
Francisco's
familiar.
fog.
It's like
Yeah.
microclimates. I
Yeah.
like you could be in one part of the city, drive 20 minutes, and it's freezing cold and foggy, and you can't
Mm-hmm.
see more than a block ahead of you. And then you could be in the sunshine, like getting a sunburn somewhere else. So
Yeah.
it really does show not everywhere is like that, but that's even impactful, right? Just like for me, even driving, it's like, oh, I need to like have my lights on now in this other
Mm-hmm.
area.
Or if you're riding your bike, right, you don't necessarily want to ride through the marine layer. Maybe somebody might not see you, right, and get
Yeah,
hit.
exactly. It can be unsafe. So, that's especially as someone that lives somewhere that has like crazy local
Mm-hmm.
microclimates, the idea of having the ability to know the difference of weather like a grocery store away from me is so impactful. And I can imagine like at scale, right, for businesses is great, but also for like the individual person, it's very cool. And a
Yeah,
lot of places have
maybe
these.
the grocery store example wasn't meant for people who live in downtown areas, but
But yeah, yeah, yeah. For more, maybe more like, yeah, more grocery store.
maybe coffee shop. I don't know. How many coffee shops does San Francisco have? I
A
don't
lot.
know.
A lot, and maybe just as much as like boba shops, but maybe like to get to your favorite restaurant
Yeah,
is
maybe your
probably like a
favorite restaurant is 3
yeah,
kilometers away.
exactly,
Yeah,
that's probably 3
yeah,
kilometers.
roughly what? That's roughly 2 miles, right? So,
Yeah. To be fair, the hills are bad, so the hills make everything a little bit longer.
I guess I was
To
basing
be
this off
fair.
of Salt Lake City, where we're a bit more sprawling out of a city than
Yeah,
San Fran.
yes, less dense, but it's still like a decent. I've been there like one time, and I felt like it was still like a city though. It's not like LA that like everything's super far apart, but
True.
LA also microclimates, right? You go to one
Yes.
part,
Yeah.
completely different weather than somewhere else. So it is so applicable for so many people that think about like, oh my gosh, I how did I just drive to XYZ place and it's so different and I didn't bring a jacket, like, or
Mhm.
oh my gosh, I'm so hot, right? I shouldn't have worn these layers. It's something so simple, that we don't think about, and sometimes we get frustrated with our weather app,
Yeah, and I
that
think
this is powerful.
a lot of that frustration stems from this old, I don't know, maybe I shouldn't use old, the legacy way of forecasting, of
Mm,
using supercomputers. And yes, supercomputers have gotten better and better and better, but running them at higher and higher resolutions costs more and more compute power.
mm,
So a lot of the time, the weather app in your phone is fed these more large scale weather models where, yeah, you don't have the information change between where you are and 3 kilometers away. So that's in the United States, we do have a high resolution model that runs at 3 kilometers that's updated every hour.
yeah,
But imagine, and the one step we've taken with Focus is that we've actually moved, we update it as fast as we have observations. And one of the observations that we have regularly in the United States is satellite imagery, which you can think of if you're sitting on the International Space Station and taking pictures with your phone. It's similar to that, but these geostationary satellites are actually much further away,
mm.
so that as the Earth turns, the satellite stays with the Earth. It's at a Lagrange point. That's what it's called.
Oh, wow.
So the geostationary, you can sit back there and take pictures all day, and actually it takes pictures every 5 minutes over the U.S. And then to complement those pictures, so we can know where clouds are, we can use our radar network in the United States as well, where we have these big golf balls. If you've seen them near airports, they're in a 10-meter tall tower. You'll see this
Yes.
big white golf ball there.
Yeah.
Underneath there, there's actually a 10-meter dish. So it's a huge DirecTV dish under there that spins and takes radar measurements around the United States globally. So we can stitch those together with the geostationary obs. So we can say, hey, we definitely know there's a storm here. Let's feed it into our AI weather forecast model to make sure it knows correctly where the storms are, and it can then propagate them forward. The
Huh.
big in weather forecasting, they're called initial value problems. So
Mm,
initial value problems, you need to know where the weather is currently to know where
mhm.
the weather will go. Same
Yeah.
thing with, like, if you're at home plate playing baseball,
Yeah.
you need to know where the baseball starts, and by the time you blink, it's moved. But your brain knows kind of where it's moving,
Yeah.
unless you're
You have an
facing an
assumption.
amazing. Yeah,
Yeah.
unless you're an amazing pitcher that's throwing the curveball, you can't anticipate it, right?
Yeah.
But it's the same
Definitely.
idea. You need to know where the weather is currently before you can move it. And if you have an error on where the weather is currently, then you're going to have an error where it will go. So if you
Mm.
constantly update these weather forecasts quickly, you're reducing the errors of misplacements of where storms are. And the idea is then hopefully that you get the correct placement and then the forecast will be more accurate after that.
Wow. Very cool.
Very
Yeah,
heavy
I
weather nut
never knew
there.
what those baseball like those sorry, those like golf ball
The
looking
golf
things are
ball
at the
there.
airport. Now I know.
It's just a
Okay.
huge dish under there, which is actually kind of cool if you're a radio or weather nerd. But I'm sure most people would be like, why is there just this big antenna under there?
Hey,
We're
now I
talking to
know, and I would
aliens,
say,
right?
yeah. Now working at Tomorrow I think I'm becoming more of a weather nerd. Like whenever I see like certain weather happen, I'm always like, I need to check our like app or our platform
Hmm.
and all that stuff. And I always want to ask someone on the science team why certain things happen. Cool. Well, that was super helpful. And I think that was really, really great like overview of kind of how we get mod like what how we receive the forecast and where it comes from and how it
Right.
impacts us like on a daily basis. Um, so kind of tying it back to AI and earlier you mentioned it, but you're also talking about those legacy ways of doing things, and well, some of us are familiar with the fact that a lot of the satellites right now that are from like other things like NOAA are starting to degrade. We're
Hmm.
really trying to figure out how do we manage this? How do we continue to keep up like the accurate forecasting so everyone's safe? I wanted to dive back into how can AI weather models enable a new kind of weather forecasting? I know you're mentioning there's an old way
Yep.
or a legacy way, and there's kind of this new wave happening that you've been brought onto the Tomorrow team to help us move towards. And how is Tomorrow's constellations, I like constellation, impacting that, which we've also kind of covered, but I want to package it up in a nice in a nice way before we move on.
Yeah. And so for people I think are familiar with our constellation, but it's not just our company that has moved to collecting data on orbit. There are many companies out there that are starting to collect these new Earth observations at a regular pace. And it's really testing the legacy method of weather forecasting. So, like I was describing before, in order to weather forecast, you need to know where the current weather is. And if you have more observations, you get even a better guess at where the current weather is. But the legacy methods, they use a method called optimal estimation, which is an older. You can consider it an AI method because there is an optimization technique in there, but it does take a lot of time for these models to converge. So a bottleneck of traditional weather forecasting has been it can't handle the amount of data we're collecting on a daily basis. I think we're on order of terabytes of data per day, if not maybe even petabytes pretty soon of data being collected from the whole weather enterprise. So this is not a sole company's effort in order to do this weather forecasting on a global scale. You need just because we're forecasting the weather of the United States, we do still need to know what the weather is like over the Pacific Ocean and even further along the globe there. We're one coherent sphere of atmosphere, and
Hmm.
we have influences of weather around the globe. So
Hmm.
we need all these different data sources globally, and we have to mesh them together into one best guess of the Earth's atmosphere at that current time. And the main bottleneck there is getting all those observations to mesh together. And there's tons of compute that is thrown at this, and it takes too long, and eventually you just have to throw a lot of the data out because it's like if you could take 10 hours creating the best analysis. That's what we call it in the weather community. It's the best state of the atmosphere. You could take 10 hours to make it, but then your 6 hour forecast isn't useful anymore, right? We already
Yeah.
passed the time that we were supposed to forecast to. So there has to be a decision point to how much data you include. So what the AI models the community is working towards is you can now have a weather forecast model that's AI based leverage more than what most of the traditional weather forecasting models use. So I think that's the first thing that AI weather models can enable is just using more data because they're built to handle data and they learn from the data and they're just better optimized for that type of situation. And I think when we're designing the traditional weather forecasting space. There's a lot of inertia in the ways we've done it in the past, but it's just it can't. We're reaching the point where I forget the name of the exponential curve law with compute, but where the amount of data we're collecting is far outpacing what our current compute resources can take without investing billions and billions of more dollars into compute than we
Wow.
already are. So I think that's where AI can help with these new kind of weather forecasting is including more data and running a lot faster than traditional weather forecast models. And then one key part of tomorrow's constellation is the weather community has never had a temporal observation such as what tomorrow's trying to provide. So
Mm,
currently, the government microwave sensors, like you were saying, a lot of them are getting much past their date of planned use. So some of them are
mhm.
degrading. There's issues with how the satellite talks to the Earth and all that fun stuff.
Yeah.
But those traditional sensors, government agencies tend to pick a few orbits, and you can then expect maybe once a day you'll have a microwave overpass of wherever you are, or maybe if you're interested of hurricanes, maybe there'll be one overpass of that hurricane for the day. The key part that tomorrow's looking to do is we're trying to decrease that revisit time down to 1 hour. So with our constellation of roughly a dozen or so sensors on orbit, we will have much more frequent pictures of storms globally from the microwave spectrum specifically. So that's something that the community's never had to kind of consider before. Is these missions cost what tens or hundreds of millions of dollars to put on orbit, so each government entity can only afford a handful of them. So
Yeah.
there's never been this idea of, hey, what happens if we actually had 20 of these sensors? Could we
Yeah.
even ingest this amount of data into the weather forecast? And now with CubeSats coming a lot. So we've miniaturized a lot of satellites.
Mhm.
I think our satellites, they say, is like the size of a loaf of bread or a cereal box. That's kind of the size
Yeah,
of our
we have
satellite.
at our office in Boston. It's, like, not very big. I was
Yeah.
shocked. I was like, "This is the life-size model?" They're like, "Yeah, it's really small," which I was shocked by because in my head, satellites are huge.
Yeah.
Yeah.
Well, that's what traditionally the government ones are. I mean, granted, most of the government sensors do more than one thing. They have more than one sensor on them,
Yeah.
but a lot of them are school bus sized satellites. So
Wow.
when you miniaturize the satellite, you can the cost to launching it comes way down because now you can
Yeah.
share a ride with somebody else who's doing some other cool science activity on orbit. So
Yeah.
we've entered a new paradigm in Earth observation where you can launch satellites for a much smaller cost, and now you can get at this temporal revisit. So you can get hourly updates of a hurricane in the Atlantic as it's sitting over there bubbling in the ocean, and we can kind of learn more. Hey, do we have to worry about this thing, or is it just going to fizzle out eventually? So if we have
Yeah.
more hourly updates, then we can be more informed in not only our weather forecast but just weather monitoring as well.
Yeah. So, it's so interesting, right? It's now we have like, it I had this conversation, I think in one of the other interviews, like, we have this surplus of data.
Mm-hmm.
Now what do we do with it? Right? And it's like the way and you're saying there's like terabytes, like huge amount of data to process. And, older systems can't process it to the speed because they weren't used to it. And so
Mm-hmm.
having to adapt and use these AI models with kind of with all the new amazing data we're getting, right, which makes our forecast more accurate. It's just necessary for everything to run smoothly, right, and things not to break down, come crashing down. Um, that was super informative, so thank you for breaking that down. I want to move on to kind of zooming in on satellites and forecasting.
Mm-hmm.
Um, Specifically, when one of tomorrow's satellite launches, what kind of data are you most excited to get, and what do you do with it? So I've had conversations about our first expert forecast was about our satellite launches and what it
Mm-hmm.
takes to get up there. I had some really insightful conversations about the different types of data we get, but it would be amazing to understand as someone that is an atmospheric data scientist, like what are you excited to receive, especially with what we just discussed on the AI models and how we're ingesting all this new data. What's really exciting for you or the community? Yeah.
Yeah, I think the thing that I'm most excited for. So these microwave sensors that we take, I don't have you covered the difference between standard imagery and microwave imagery?
I think we might have a little
A
bit, but
little
it'd
bit.
be great for you to do a breakdown. I think it would be awesome to hear about it.
Yeah, so we've talked about microwave a little bit already, but so we're just talking, yes, this is the microwave that your microwave in your kitchen operates at. But for our sounders, they're called sounders, is that we're not emitting at microwaves. We're just absorbing what microwaves come from the earth. So
Mhm.
every object, you and I, we all emit a spectrum of wavelengths of energy. And the hotter the object, the shorter the wavelength or higher the frequency uh, of energy that gives off. So the earth is warm, relatively warm, and it emits at a wavelength. We talk about one of the ones we're observing at. It's like 3 millimeters. So that's the
Mhm.
W band. So that's what maybe your pinky's 1 centimeter, so
Yeah.
much smaller than your pinky wavelength of energy.
Okay.
But we're taking pictures in that wavelength of the earth, and what happens is clouds and ice. So inside of clouds you have small little water droplets and ice crystals, and those
Mhm.
ice crystals and water droplets can then scatter away the microwave emission. So if you imagine you're staring at a light and some little particle flies in front of the light, you can then see that particle in its shadow. So
Mm.
similarly with our microwave observations from space, we're looking at some of these shadows from clouds and thunderstorms getting in the way of the microwave emission of the earth.
Wow. So,
So
so
what
interesting.
makes me excited about our satellites is this idea that these microwave sensors are actually more sensitive to precipitation. And so I come from a background of doing a lot of precipitation research throughout my career. So that's something I get excited about. And the really unlocking potential, especially on a global scale, is this hourly update of precipitation globally. So you can imagine, in places over the US, we were talking about those golf balls earlier. The US spends lots of money having these surveillance radars on all the time. So we have a good understanding of where thunderstorms, snow, where that's all occurring at a good clip around the United States. But imagine you're out over the ocean, you're you have a big ship like full of freight that you're shipping from the US to Europe
Yeah.
or whoever knows. There's no radars out over the ocean, right? There's nowhere to put them. They have to be on something. So
Yeah.
our next best guess at precipitation would be maybe just take your iPhone pictures from space, but then you only see the top of the cloud. So that that's
Yeah.
the hard part, where these microwaves can actually probe through the cloud and see, hey, how much is there? A lot of rain here? Is there some hail? We can see those types of things from the microwave signals. So
Yeah.
that's what makes me excited, and what I actually do with it in terms of for work here at Tomorrow. We were talking about ingesting it into the weather forecast, so I've been building it that way. But something also that we've been starting to look into recently has been more of the hurricane side of things, and
Yeah.
using the microwave imagery for hurricanes to learn how those hurricanes are strengthening, weakening, all that fun stuff.
Yeah. Those our hurricane images are pretty amazing with from our satellites. Yeah, I think it's really interesting and something that I learned joining Tomorrow and a lot of people don't know is just like the gap of weather knowledge over
Mm-hmm.
the ocean. And our planet is mostly ocean and there's a lot of things, right? There's big ships, shipping crates,
Mm-hmm.
and there's lots of accidents that happen every year with them and that's millions of dollars lost,
Yeah,
for those
even if it's
businesses
just
that are
late
relying on them.
even if it's just late by a couple of days,
Yes.
it's such a global integrated economy now that, I mean, I personally get frustrated when my packages are late too. So
Yeah.
I've gotten so
And
used to quick deliveries that if your freight hauler is late by a few days, then it goes late through customs, and then yeah, you
right
just
through everything. And that
economic
was, I
loss.
remember, such a big deal back in 2020. We really everyone kind of actually had an understanding for the first time
Hmm.
the how things
Supply
move
chain stuff, yeah.
globally. Yeah, supply chains, and it was like such a I never thought about it until then, and when everything was delayed because when one thing delays, everything else does. And it's this,
Hmm.
it's a overall a massive cost in so many ways, like you were saying. But yeah, it was really fascinating to learn joining. And I think the average person does not know that we just do not, well, not now we're starting to provide that at Tomorrow,
Hmm.
but for the longest time, we really didn't have real weather information over the ocean, which is
Hmm.
a large part of the planet, and that we all have to, navigate, for whatever reason, getting our Amazon package or taking a flight or whatever it is, going on a cruise,
Yeah.
all those things. It's important. So that's really helpful, and I think a really great way to explain why it's important. Um, so I would like to move on to another question,
Sure.
around, satellites and forecasting. So how do, the experiments we're doing, around weather forecasting and the models and everything that we're doing impact weather forecasting for people when they see it in our Tomorrow dashboard,
Mhm.
or see it in an app, right? See it in the weather app, or if they have our Tomorrow app. How does it all come to the consumer? Um, yeah,
Yeah, and it's the measuring it on that scale is always kind of a hard thing, like the
yeah,
moving to the end perception of it. But
yes,
I think how these experiments improve our weather forecasts are when we build these AI weather prediction models and we're ingesting the latest data, the goal is to minimize our error. And maybe
hmm,
that doesn't always include every single weather event. And I think a lot of times weather forecasters and phone apps get a bad rap because people always say the moniker of the weather forecaster's always wrong. They never get it right.
yeah,
Unfortunately, I don't think the field will ever shake that. So we have the numbers to show that forecasts are getting better, and it's about a day per decade. A 5-day forecast today is as good as a 3-day forecast 20 years ago. And
yes,
that's a lot of those improvements have been slow improvements to the weather model, slow improvements to more data being collected. So, specifically with our constellation, we're only one small piece of the full weather forecast. And so end users, for some cherry picked forecaster, they might not see the benefit for that specific forecast. But I think if you're using an app or the dashboard specifically, and we've tuned the model to specifically minimize alerting you about rain. Maybe that's something you care about as a consumer. I don't know, maybe you run tennis tournaments for whatever
yeah,
reason, and you need to know to a high precision if it's going to rain because we can't play tennis in the rain. People slip and get hurt. So if we've tuned those forecasts for raining, uh, over time, statistically, you should get a better result than just if you just did one event and just used a non-tuned model. So that I think
yeah,
that's where our experiments are looking to tune these weather forecasts for specific needs. And
hmm,
then on a statistical result, say over the whole summer season, you'll see that, hey, on average, we were doing better at predicting when to stop the tennis tournament than if we used the old untuned model. I think
yeah.
that's where people actually see the benefit from all the work we're doing.
Yeah, the hyper localized
Yeah.
ability to forecast, and I think also the average impact, right, is
Mhm.
better. Yes, I think in general weather gets a bad rep, just like anything that people are kind of looking at on a daily basis, right? There's variability, and it's because we're basing it off a model and prediction that it's
Mhm.
never going to, we can't say every day, at least not right now, there's 100% accuracy, but the accuracy is getting a lot better. But when people are using an app and looking at it every day, and it people can get mad
Yeah, and
about
it's
it. But
hard
what
to
can
it's
it's
hard to
not.
tune a forecast for everyone's needs, right?
Yeah,
So a lot of the thought is you do one forecast model that does a lot of things generally well.
yeah,
But if people are hard to please because I mean, like I said, the example, maybe I'm playing tennis, but then somebody else doesn't really care about the rain because they actually want it to rain, where I don't want it to rain because
yeah,
maybe they're growing their vegetables in the garden need water, right? So
yeah.
there's different competing interests, and you can't really have one model that does everything, at least currently,
Yeah.
unfortunately.
Yes, exactly. And, an app can't predict also right now, at least where you're going to be. Well, at least
Sure.
when we're doing our platform and working with businesses, we know where they're located. We
Hmm.
know where they're going. They can plan for it. But my weather app, when I was living in New York, doesn't know that I'm going from downtown to uptown. And yeah, like even though it's a small island, going from Lower East Side to Upper West could be completely different, like weather
Hmm.
forecast. But how would it know? How does the app know that I'm
Yeah,
going? It
unless you
doesn't.
explicitly plugged your route in, maybe it could.
Exactly. And the weather app on the iPhone, because I have the iPhone, doesn't do that. While
Mhm.
our platform is better about that localized. And if you we once you put your locations and your routes in the system, right, it's checking it along the way, while the
Yeah,
average
it,
B2C consumer doesn't
and it will
have that.
also alert you for specific things you care about. Yeah.
Yeah, exactly, exactly. The things you care about too, because farmers want rain, while
Yeah, or if
and
you're
while maybe the average me and I'm wearing sandals, I don't want rain.
yeah,
But
or
how
if
does
you're
he know I'm wearing sandals versus closed-toed shoes,
or
right?
if you're riding your bike to work and there's going to be a strong headwind that day, maybe you don't want to ride your bike and you want to take the bus instead, type of thing.
Exactly. Exactly. Yes. Yes. So now I'd love to move on to how you know, how we purposefully innovate at Tomorrow, how your team is doing that. And you have talked about your interest in precipitation and your experience just in the industry and in the weather community in general. I'd love to get also an industry perspective
Mhm.
today. So the question I'd like to ask you is, how is Tomorrow taking a different path from the rest of the industry with our approach? And I know we've covered a little bit throughout kind of your answers, but I'd love to just have like a clear answer on that.
Yeah, I think one of the innovative parts of tomorrow compared to the rest of industry is that we've kind of taken the full approach of like end to end approach. We're not just a software company. We're also collecting our data and we're taking that data to then influence our weather forecast to then feed it into our own platform to build whatever tools that people need. So I
Yeah.
think that's one of the innovative parts is we have that end-to-end coverage from the data source all the way down to the API where people can hook into it for their specific needs. So that's the truly differentiating part at the moment. And space is not easy. I think that's the craziest thing to me when I was watching what Tomorrow was doing from the community perspective. I Joe Munchak, I worked with him while he was at NASA, and I saw him working at Tomorrow, so I was kind of keeping an eye on what the company was doing, and
Mm-hmm.
it was mind boggling that a company was able to launch their own satellites that were collecting the data that I was using in my PhD of like doing research on. I'm like, why is it's kind of interesting. How does a company put satellites into space and use that?
Yeah.
Like I thought these were reserved for kind of just societal benefit. Let's build a sensor and do a lot of foundational research on it. And then I didn't know that the price of going to space has come down so much that it would make it viable to make better weather forecasts and that a private
Yeah.
company could lead that effort. That was kind of mind boggling to me and
Yeah.
exciting too.
So exciting. I mean, even when my first episode of this, I was talking to Jack Dallimore, that I think it was just insane to understand how quickly we've been able to do things too,
Yeah,
and that it
it's
has
been what
become
one
even.
year.
Yeah, it's insane, and how often we can launch satellites, and it was
Yeah.
impossible probably 5, 10 years ago. It felt, at least it felt impossible for a startup to do something like this. And again, and the idea of rideshare now, I like cracked up when I first heard that. I'm like Uber,
Yeah,
and
basically, yeah.
it's like it is. It's like a
You
rideshare
don't
up
order
into
it on your
space.
phone, but it's
Yeah,
basically the same
exactly. A
thing.
little bit more complicated to get, to
Yeah.
your destination, but with those school bus sized, satellites you're talking about, that was not possible. While now, when we are able to make them more compact,
Mhm.
multiple things can go to space, and private companies are able to do things that are impacting their industries. And in our case, it's really impactful to the weather community, which is really cool, and really cool to work somewhere that is doing that. And I
I
think it's
agree.
also interesting to hear that, as observing from afar, when you weren't even working at Tomorrow, you were like, how are they doing that?
Mhm.
And it's something that I hope that in this series we're answering for people of how
Mhm.
on earth are we do how on earth are we doing the things that we're doing at Tomorrow, because it's a very unique company. I think it's very special to work here. Um, so, what are the biggest challenges in getting satellite data into weather models, and how are we overcoming them? So, I know you talked about, the size, like the
Mhm.
mass, the data amount. But are there any other challenges that you feel like are that you're interacting with for the weather models?
Yeah, I think maybe some people have heard this saying that's been out there is that your AI model is only good as the data that go in, right? Garbage in equals garbage out.
Yeah,
So it would be one thing to have satellite sensors that are not making very good measurements, and it wouldn't really help your weather forecast in the end because it's too noisy or maybe too irregular, and it's just not helping out weather forecasts. But at Tomorrow, we've actually shown that even though we're a much smaller sensor, we've had to make some changes to the satellite to make sure we can fit on there with the power requirements and the choices of the specific wavelengths that we're taking measurements at. But it turns out that we're actually making high quality observations on a much cheaper platform. And I think
Hmm.
there's been some posts from the company about the independent evaluations from the JCSDA, I think is the acronym.
Yes.
And JJ and Ryan, I think Ryan's been on this show before, of
Yes.
they've been feeding it into traditional weather models. And for those who don't understand, or maybe haven't been exposed to it, is that these physics-based weather models do not like bad data, and
Mm.
they will just explode. Like, not the computer won't explode, but the weather
Yeah.
simulation will explode. And for those who are in
Mm.
the weather community, that's the CFL errors that we always get when if you ever tried to run a weather model. It's like basically inside the weather just goes unconstrained because that observation was unconstrained. Like, say is super
Mm.
noisy and didn't really characterize the weather as it's supposed to. So it's always a big challenge is when you have some new sensor getting it into those physics pipelines is you need to have high quality data. And luckily maybe not luckily, by design, our sensors are collecting high quality data that have been able to fit right into weather models, the traditional ones, as well as the AI weather ones we've been building.
That's really
They have been working there, collecting good data. We're still running into some size requirements. I mean, even though I'm training AI weather models, like I said, on more of a single GPU, that single GPU still has memory constraints. So still playing the fun games of how do we get all of this data to pump through this weather model still. So,
yeah. Yeah, that's interesting. We spent a lot of time about the data side of things when I was talking to Ryan,
mm-hmm,
and and the importance of like kind of the almost like, and maybe this is because I'm in the business side, market side, I'm like data cleanliness, but it
mm-hmm,
actually just it's important for everything because it's like even when I discuss AI with other people, it's like you get what you give it,
mm-hmm,
and it sounds like it's on another scale of importance that you get what you give it. If you give it something that's unclear, like in a lot of ways, you can think data as instruction, right? Of
yep,
move
exactly.
forward with this XYZ, right? It's like an equation, and right, it's physics.
Mm-hmm,
And if you give it bad information, it won't work. You won't get what you want, or as you put it, it will explode. So obviously not physically explode. We're not
yes.
like dealing with like a James Bond explosion of like a
Just
computer data
in
sensor or something.
simulation explosion.
But yeah, but more of like it will
Yeah, like
not
you,
work.
you get weird things like absolute zero in the atmosphere, which makes no sense physically.
But it's like, those who are really interested in this and do equations a lot, or those who maybe haven't done, a really complicated equation since, university or high school, right? It's like putting in the wrong variable, you'll get and put it in the calculator just gives you like error.
Mm-hmm.
So right. It's just you won't get anything, a real result out of it if you're not giving it the right thing, which is important. Okay, well, we're coming to the end of our interview. So I want us now to end on kind of a note of looking forward and talking about, especially, you say you're very involved in the weather community. Like, what about kind of the next generation, and people aspiring to be, in the weather community, being on the front, the frontier and the front edge of weather science. So the first thing I'd like to ask you is what excites you most about the next generation of weather satellites or the next big advance in numerical modeling, and what's the impact it'll have on forecasting?
Yeah, I think that's our current constellation we're calling Gen 1, I believe, is it's exciting and it's not something that many others have done. And I think this is just the first stepping stone to the next generation of weather satellites. So we're just showing what possibly can be done. And hopefully, our sounders we've built to design in general, it's called the sounders because it's making soundings, or if you think about like a balloon, a weather balloon, it's
Mhm.
taking this profile throughout the atmosphere. So these sounders, we had their resolution for precipitation, something that I'm quite interested in, is not the greatest. It's on the order of 15 to 30 kilometers. So
Mhm.
they're still relatively coarse, but I think as we move into the future, beyond just as the weather enterprise, having a constellation of more than just sounders, we'll have imagers, Maybe the community, some other people provide radars from space, which is something I worked with a lot in grad school. So I think the ability to have all of this information content globally is something that really excites me. You can go from everything from knowing the temperature to how hard it's raining to, hey, there was hail here. Like that's just something that I'm sure people 30, 40 years ago just didn't even dream of. Hey, you can have hourly updates of every point on the earth globally, which is just really exciting. And I think
Yeah.
it'll unlock a lot of forecasting, such as the nowcasting stuff of your plane. Maybe turbulence will be less because now the planes will know more of where storms are, which storms to avoid, and which ones they can fly through.
Hmm.
Hopefully, that'll lower your delays at airports, and that they don't take a layover delay for no reason. Those types of
Yeah.
things. So I think that'll be the end impact. Is just life as we know it will hopefully get more smooth, and you'll have less weather interruptions just because our capabilities have gotten better.
I would love that. I would love no turbulence or no
Well, you won't
delays.
have no turbulence, but
No, I know,
I,
but one can dream. But
well, I
even
mean,
just the ability to know, like, I would much rather know hours in advance my
true.
flight's going to be delayed, so I don't show up to the airport and I have to sit there
Yes, so
for
you don't
three,
go through
4 hours.
security, and you'll get to
Yes,
have
exactly.
lunch at home instead of at the airport, right?
Much rather, and much rather make myself food than pay like $20 for a ham and cheese sandwich.
Yeah.
Um, but that's really it's exciting to think about. Okay, and the last question I wanted to bring up was for young people inspired by this work, what skills should they start building today?
I think young people should definitely explore AI for their toolbox, but not use it as a sole method for everything. I
Hmm.
think it's easy to get into the framework of, well, we'll just have AI do it. We'll have AI do it. At
Hmm.
some point, there still needs to be your understanding to help guide the AI to where you need it to go. So I think for young people who are inspired, like, don't throw away your radiation course in school, because you still need to know how the atmosphere operates in order to anticipate what these images will look like and how to debug with the AI as your partner or as your co-coder to build
Yeah.
whatever you're trying to build. So I definitely take the time to learn how to use these tools in a way that accelerates yourself as opposed to incurring. I think the term they use these days is technical debt. Right? If you don't spend the
Mhm.
time to learn how to do it, and then you suddenly have to do it without that AI, you can't do it, right?
Yeah.
So
Yeah.
I think that's,
What if it breaks?
yeah.
What are you gonna do then?
So
Yeah.
I think it's an exciting time to be a young person starting out at college. It might be a lot of people are pessimistic about going forward of where jobs will be and where they won't be. But I think it's also a very exciting time of, you have the freedom, maybe not freedom, but like the opportunity to use this tool to accelerate yourself faster than anyone else has in the past.
Yeah.
And I think that's the really exciting part for people starting to. I'm a self-taught programmer. I wouldn't even dream of building an app while I was an undergrad because I didn't even know how to program in undergrad until like later in my undergrad years. Now freshmen can show up at university and they could build their own app with the help of one of these tools and not even have to worry about
Yeah.
the coding side of things. They can just bring the idea of like, hey, I want to build this weather app
Yeah.
for, I don't know, my walk to class, right? And what
Yeah.
it needs to tell me, hey, should I wear a sweater this morning or should I expect to put my galoshes on, or whatever you want to call them, right? Bring an
Yeah.
umbrella. I don't know. Like it seems like there's a lot of opportunity for people to build a lot of cool things without having to be an expert in computer science as well as weather. I think that's the cool thing.
Yes. Definitely. I completely agree. I think that AI is great and it's an amazing tool that I think can, right? I have no coding experience and I was able to make like a landing page on like of a website
Mm-hmm.
with AI, which is nothing I could ever thought I was able to do with my current skill set. But at the same time, something's also helping and feeding these models, and you need the background knowledge, whatever you're doing with AI. And how do you know it's good or what the output is good if you don't have the technical knowledge behind it, right?
Hmm.
Like if you're not a, if you don't ever learn how to write a good paper or good copy or whatever it is on your own, like this is from my perspective, how do you know what you're getting from the AI is good versus just awful writing?
Yeah,
Well, you
it's really
won't
hard to
unless you.
trust. It's really hard to trust something that you can't anticipate how it's going to fail, right? So
Yes, and
that's
so I
that's the
think
biggest thing is if you know the weather data, or I guess that's the example I've been using. But if you're the domain expert and anticipating, like I know the world spins this direction, right? This the hydrostatic balance. Like I know these rules that can't be broken, and maybe the AI right currently might break them, and I have to be able to correct it when it shouldn't. Yeah,
yeah, I
that's
think that's
that's a
just
terrible ending.
no, but yeah, but it's I think I would say that's so important and a really good piece of advice for people entering the workforce and in general, let alone weather. But I also want to use this as an opportunity to plug something that we are working
Oh
on
yeah, of course.
that is about models
Hmm.
and being part of kind of the next wave of things. I think I'll let you kind of take it off because
Sure.
I think it's really interesting because you're working on it
Yeah.
and you would be supporting this community. So
So we've recently announced that we're doing this Build Tomorrow initiative, and our first challenge for this Build Tomorrow initiative is a hurricane intensity challenge. So we already talked about in this a little bit about how microwave imagery gives us sort of an X-ray-ish type of view into these storms, and knowing where the strongest thunderstorms are in a hurricane correlate really well to how strong it is or how strong it will get.
mhm.
So something that we're exploring for this first challenge, and we want to ask the community to participate in, is we're going to have this giant database of simulated microwave observations of hurricanes. So we've taken the NOAA archive of weather hurricane forecasts, like these simulated hurricane space, and then we've taken some code that Joe Munchak has built to simulate what our TMS sounder would look like as if it overflew that hurricane in the simulation. So we're going to have
Love
a
it.
bunch of these hurricane images at regular intervals, and we want to ask the community if they want to get their hands dirty and start playing around with the data and build their own uh, hurricane intensity forecast for these images. Ultimately, so we can then run this in real time with our on orbit constellation, so we can give near real time forecasts of hurricanes with the real data eventually.
Yeah. Just to add, I think it's, kind of tying it into the next gen of those interested in getting into this industry and into weather. It's a great opportunity to just like work with some you were observing from when you're working somewhere else,
Mm-hmm.
working with a company that's doing something very different, working with new AI models, our own satellite data, and get your hands dirty and get that experience beneath your belt. And, I think it's just a great opportunity for students or, developers. But, I think about that student community and what a cool opportunity it would be to just try
Yeah.
something before I graduate, right? And really experiment with it. And what a cool opportunity to go say, I did this. And
Mm-hmm.
I worked with, this community with this, kind of up and coming other company when they enter the workforce,
Mm-hmm.
with the nerves going on with AI and how the workforce is changing. I do see it as a really cool opportunity in that way too, beyond the a very cool scientific opportunity as well.
Yeah, and it's something that we have a relatively small data science team here at Tomorrow, and it's something that we wanted to explore. But if we had the community pitching in as well, of think of all the different avenues we could potentially go
Yeah,
down of how we can best make this model work, I think
yeah,
that'll really truly open up some access to better forecast of hurricane intensity than we have had previously, especially with the new novel microwave sensors that we have on orbit.
yeah. So cool. Well, with that, thank you so much, Randy,
Hmm.
for coming on, being one of our really special guests at the Expert Forecast, and I appreciate all your knowledge and taking the time to share with us your perspective. So,
Thanks for
yeah,
having me.
yeah,
Always
great.
happy to nerd out about some weather stuff.
Yeah, I love it. I feel like I learned so much doing these. So, thank you.
Happy to help.